Hello, everyone. There is almost always misunderstanding about what the sampling distribution of a proportion means. Here's the idea. Let's suppose we have in a gigantic bin 1,000,000 marbles. 300,000 of them are red, and the other 700,000 are white. So that means 30% of them are red, 300,000 out of 1,000,000. So our proportion of success is 0.3. That's 30%. Let's suppose that I am going to draw just 10 marbles at random from that gigantic bin. You would expect 3 of them to be red. Let's see what happens. I'm going to just draw one sample, and it turns out 4 of them were red. Well, it's random chance. That could happen, right? 30% of them are red, 300,000. We might have 4. Let's draw a second sample. Oh, that time only 2 of the 10 marbles were red. So if you look at the frequency, half the time we got a p hat of 2 over 10, and half the time we got a p hat of 4 over 10. Let's draw a third time. That's interesting. I don't know what happened there. Oh, I guess we're off the scale someplace. Oh, that time none of them was red. That's what happened because the mean is 0.2, so that time it was 0, and it doesn't draw a bar here for some reason. Let's try it again. That time, oh, finally, 3 of the 10 were actually red. Okay, so we've had 4 draws. One of the times, none of them was red. Another time, 2 were red. Another time, 3 were red. And another time, 4 were red. And we could do this over and over again. That time, 5. That time, 3 again. Okay, that time, 3 again. That time, 2 again out of 10. But let's do this 100 at a time. Now, let me explain. This is as if I push the draw button 100 times. So we're drawing out 100 samples of 10 marbles, and we're looking at what proportion of them are red. Okay? And if we do that, well, now we're up to 108 samples of sample size 10, and look at that. About 30% of them had 3 marbles in them, about 22% of them had 4 marbles in the sample, and so on. Let's make it even more. Let's go with 1,000 samples. Okay, so this is like pushing the draw button 1,000 times. 1,000 samples of size 10. Oh, now that's what the sampling distribution looks like. Again, it's not showing the 0 bar, but some of the time 0 of the marbles were red. But about, oh, it looks like 25% of the time, 3 of the 10 marbles were red. About 21% of the time, 2 of the marbles were red. Same thing for 4. Very rarely were 8 of the marbles red, or 9, or all 10 of them, although that might happen some of the time. As you can see, this distribution is centered on the mean of 0.3, okay, and it is skewed to the right. The reason it's skewed right is because, remember the n times p and n times q rule? Well, if we take n 10 times p, 0.3, we get 3, which is not greater than or equal to 10, so we expect it to be skewed. How can we make it more normal? By increasing the sample size. So let's start over. But this time, instead of drawing out a sample of 10 marbles, we're going to draw out a sample of 100 marbles. Again, 30% of all the marbles in the entire bin are red. Okay? And again, I'm just going to draw out one of them, one sample of 100. And so on that particular sample, 35 of them were red. And that's why it says 100% here. On our second sample, I don't think I clicked it. There we are. Oh, the second time 35 were red also. I just didn't notice that. On our third sample, 32 of them were red. Okay, so 1/3 of the time we got 32 red marbles, and the other 2/3 we got 35 red marbles. Let's draw out another 100. That time 30 of them were red. Hey, how about that? That's what we expected. The others were all a little bit high, weren't they? Let's try it again. Oh, that time 30 were red again. One more time. That time 30 were red again. Oh, okay. So now we seem to be fixed around 30. You'll notice none of these are up at 60 red marbles, and none of them are down at 3 red marbles. So let's increase it to 100 draws of, well, let's make it 200. 200 draws of sample size 100. Count how many are red. calculate p hat by taking the number that were read divided by 100, and then mark it on our graph and do that 200 more times. And boom. Oh, now look what's happening. It's starting to center around right there is 30. That is 3/10. Okay? Now 200 samples is quite a few, but it's not that many. Let's go up to 20,000 samples. This is going to take the computer a while to do it. Oh, but it can only do 10,000 at a maximum. Well, look at that. We've done 10,206 samples, and look at that. It's centered on 0.3, and it is quite normally shaped, isn't it? Let's do another 10,000. Look at that. It is normal. The sampling distribution of the p hats are normal, even though it is a skewed distribution when we use a small sample size. That's because n times p, 100 times 0.3 is 30, and that's greater than 10. And n times q, 100 times 0.7 is 70, which is greater than 10. So the sampling distribution is normal with a mean of 0.3 and a standard deviation of 0.046. Oh, that's that square root of p times q over n. And that's how you calculate the standard deviation. And that's what we mean by the sampling distribution of p hat. I hope that helps.